That hardly seems fair. I'm just saying. Okay, let's do some math here. So 6th grade wants you to be smart and do 7th grade math. And they said, let's show the kids cool math videos. And they did exactly that, except someone forgot about the cool part, and they just found boring, awful videos. And you know what? This is America. And there are rules in America. It's called the 8th Amendment. Look it up. It says no cruel and unusual punishment, which is what those videos were. So let's pretend this is interesting and do some math. Okay, let's go. So today we're talking about how to model multiplying. Oh, I still spelled that wrong. Multiplying fractions. Okay. Now the best part about multiplying fractions with models is that as soon as I show you how to do it, I'm going to explain to you why it's terrible and why you should never do it ever again. So be ready for that. Also, we're going to make this fun. So at some point, expect to see explosions and hashtags and angry cats with words written around them explaining why they're angry. Okay, so 1/3 times 3/4. Let's get to the task at hand here. So 1/3 of this, we're going to find 1/3 of this box, and it's conveniently broken into 3 columns here. So hopefully you drew your box, and you're going to split it into 3 columns with perfectly straight lines, just like these. You can pretend these are perfectly straight. Okay, and then we're going to shade in one of them. So let's shade it in here. Shade it in, just like that. Okay, all right. That's 1/3. Now we're going to come over here, and we're going to shade in 3/4. So we can't do it with this because this is thirds, so we have to go the opposite direction. So if we made columns with 4, we have to make rows with this one. And it just so happens, hey, look, we have 4 rows here. So let's split this into 4 rows. Again, straight lines as possible. 1, 2, 3, and 4. Okay. And now, since we just want 3/4, we're going to shade in 3 of these, 1, 2, and 3. So let's do that here. Okay. Bam, shaded in. All right. Don't go all crazy when you do it, as long as you get the idea of what's shaded in. And if you use lines going opposite directions, it's a little bit easier to see if you don't have multiple colors. But if you do have multiple colors, hey, give your parents a high five because they prepared you for school. Yay. All right. So, task at hand, what is the answer to this mess we've now made? And our answer is going to be what's shaded twice. So what is shaded in red and blue? And we see we have this section here. And since it's blue and red, that would seem to me like that would make purple. So let's box this off in purple. And how many little boxes are shaded in twice? Well, there's 3 of them. Out of how many total? Well, we have 4 rows of 3, so that's a total of 12. Okay, so 3/12 is our answer, but you should hopefully know that that's not your best answer. We can simplify this. We say, what can we divide 3 and 12 by? 4. You can't divide 3 by 4. You can divide it by 3, though. Good try. You know they don't. Who knows? Okay, 3 divided by 3, that's 1. 12 divided by 3 is 4. And we have an answer. 1/3 times 3/4 equals 1/4. And you say, hooray. Actually, you probably don't say hooray. You probably say, oh, who cares? But then I say, look, here's an explosion. And you're like, oh, yes. This is totally middle school now because it's got explosions. Okay, 1/4. And we're going to look at why this matters here in a second. But let's look at some big picture stuff here. Now, since you have a great math teacher, look at your math teacher and smile. Give him a thumbs up to let him know they did a great job with you. And you know that 1/3 is a decimal. That's about 0.33. Okay, and you know 3/4 or 3/4. That's 0.75. And then 1/4 is 1/4 is 0.25. So what we said is that 0.33 times 0.75 equals 0.25. This is a true statement. You just did it. Okay. But now here's the thing. 0.33, 0.75, those are your factors. And both of these are bigger than your product, than your answer here. Okay? And this totally goes against what they probably, since 3rd grade when you started multiplying, they said, well, Billy, or Johnny, or Susie, whatever E, when you multiply two numbers together, you're going to get a number that's bigger because multiplying it makes things bigger. And you said, okay. And that seemed all well and good. But right now, all those years, this was good. And now Ellis comes by for one day and says, number gets smaller. Ha ha ha. Right? So what just happened? Why is it that I multiplied two things and it got smaller? So let's take a look at that because this is kind of a big deal, right? And we don't want to assume that your math teacher lied to you, right? Look at your math teacher and say, would you lie to us? Okay, hopefully they said no, they would never lie to you. So let's look at some basic math facts here. 4 times 1, 4 times 2, so on, and we should know these answers. And we see as our factor here gets bigger, so does our answer. And that's natural, right? But now we think about it, instead of thinking about it getting bigger, we talk about fractions. Those are small numbers. So instead of looking at it as getting bigger, we look at how our products keep getting smaller as we get closer to, let's put it down here, 4 times 0, which is 0, right? And why leave all this space here? What are all these numbers that fill in this gap between 0 and 1? And you say, of course, what about our fractions or decimals? So when we say 4 times 1/2, and this is going to get into a whole different thing about how multiplying with fractions is the same as dividing, but that's a thing for another time. But we know that half of 4 is 2, right? Half of 4 is 2. 4 times 1/2 is 2. Okay, no one's arguing that. But now look, here's your factor, and it's bigger than your product. So what's going to happen always, forever, as long as you're alive, and then even when you're not alive, which is sad, we'll miss you, but this math will still be true, that if you multiply by something less than 1, your answer, or your product, is going to be smaller than what you started with. Okay? And that's why in this case, we multiplied one decimal by another decimal and got a decimal that was even smaller. So that's pretty neat, right? Okay? But this is boring. Who cares? 1/3 times 3/4, and you make pictures and hooray, but it's boring. All right, we can do better. Okay, so let's rethink about this, but let's do it with pizza. Because if I'm talking about fractions, I want to talk about pizza. Okay, everyone likes pizza. If you don't like pizza, you're wrong. Go get some good pizza. Okay, this right here, this is not good pizza. This is the first picture I found, and I don't know who's making this pizza. It's got tomatoes on it, and it's got like beans and what looks like mold. And it's got yellow stuff like queso. And pie crust. This looks like a no, not queso. It's supposed to have cheese like this. Look at this pizza. This is quality pizza right here. It's got some pepperoni, and the cheese is like golden brown, and it's got peppers on it. Still looks a little moldy, but whatever. It's got sauce. It's got a proper crust. This is the pizza we're gonna work with, right? Right? Get excited. Okay, get hungry. Get hungry for math. So here's our same problem: 1/3 times 3/4, and let's think of it in terms of pizza. Okay. So we're going to say 1/3. And 1/3 is going to represent how much pizza we have left. So we have 1/3 of a pizza left. Okay. I don't know what happened to the other 2/3, but it probably involves me eating it. And we're going to say, we're going to split this between 4 people. That's what this 4 is going to represent. Okay, so split between 4 people. And then for some reason, just for fun, we want to know, out of those 4 people, how much of the original pizza will 3 people get? Okay, it's a super obscure question, but why not? Why not? This could be fun. So let's take a look. Okay, so we split this up into 3 pieces. It's looking like a very peaceful pizza. Peaceful, right? Okay, so we need to pick one of these thirds to be left, and I like this third. Okay, this is the third we're going to look at. Okie dokie. Okay, pretend that's a perfect curve. Actually, don't pretend. Let's try again. I can do this. I can do it. There we go. That's much better. Okay, there's 1/3. Now what we're going to do, we're going to split this between 4 people, and the easiest way to split something between 4 people is to make 4 even slices, right? So let's try to do this as best as possible. 1, 2, 3, 4. Don't laugh at my pizza. I saw the one you drew in your notebook wasn't much better. Okay? Okay, deal with it. Alright. So, we want to know how much 3 people would get. So here's 1 person, here's 2 people, here's 3 people. So this is the part of the pizza that we care about. And then we can even kind of see it right now. But this definitely looks like 1/4, right? Which was our answer. But just to be sure, how can we determine the exact fraction that's left? So we split this into 4 pieces, and that's nice, but we can't compare it to these ones because now they're different sizes. Each of these is 1/3, and each of these is some fraction we don't even know. It's 1/4 of a third. So what we have to do is we have to split these ones into 4 pieces as well. Okay? So even though they're not there, they're in my belly, we're still going to split them up. Okay? As best as we possibly can. Okay? And the reason why we do this is now we can count up how many total pieces of pizza do we have. So let's just go around the way here. We have 4, 5, 6, 6, 7, 8, 9, 10, 11, 12. It's like a Sesame Street moment there. It's good quality counting. Okay, so how much did those 3 people get? Well, they got 3 pieces out of a total of 12. And hey, guess what? That's still 1/4. And that's still the answer we got, not here, but here. Right? Explosions. Who wouldn't be happy with this? Right? So that's 2 ways getting the same thing. Who wouldn't be happy with this? Where did it go? Oh, forget it. There's supposed to be. Never mind. Save it for next time. Okay, there's problem 1. And we said, why is this a terrible idea? Well, let's come back to that. Let's do one more. Okay, so the second thing they wanted you to look at was how to do modeling when you had mixed numbers, which is interesting. But the lady that tried to do it for you, she was the opposite of interesting. She was, I don't even know what the word is because I don't like to think about uninteresting things. So she said to start off by estimating. So 2.5 by 3.5, that's close to 2 by 3. So we can model that by saying, what's 2 by 3? Right? So if we think of a rectangle, that's 2 by 3, and you say, what is the area? And you just count up how many squares does this take up. And we say 1, 2, 3, 4, 5, 6. So the area of this is 6, which means 2.5 times 3.5 should be approximately, that's the symbol here, or about 6. We're looking for an answer relatively close to 6. Okay? But we don't want relatively close, we want exact. So I want to know what this times that is exactly. So we're going to need a better picture than this. Okay? So we're going to expand this. We're going to say instead of 2, we're going to say 2 and 1/2. So use your imagination. Say that's about 1/2. Okay, 2 and 1/2 by 3 and 1/2. So we're going to go down 1, 2, 3, and 1/2. We're going to complete our box. It's a little bit big, but okay. Oh, hold on. I can do this. I can make straight lines. Bam. Okay, close enough. It's 2.5 by 3 and 1/2. And now the question is, how many squares does this take up? So it's not quite as straightforward as it was before, but we can still count up our full squares. We have 1, 2, 3, 4, 5, 6, right? Same as before over here. But now we have parts of squares. And so if we say if this is a half, so this would be half of a square, and this is half of a square. So that's one whole square right here, so we can call that number 7. And then down here, we have a half. I mean, it's a little bit more than a half, but my lines aren't the best. Okay, deal with it. So we have half and a half. That makes one whole. So that's, well, that was 7, so this will be 8. So now we have 8 squares that this takes up. Right? Stay with me. We're almost there. And then we just got these little leftover pieces that nobody likes, but we gotta deal with them anyway. You know those kind of things, right? So here's half of a square. And here is, well, this is half by half. So what's a half times 1/2? Well, half of a half, that's just 1/4. Okay, and we're going to talk about why that is in just a little bit. Almost forgot. We got to do that. Okay, so what's left over here? So we have 1/2 plus 1/4. Okay, and then since you have a great math teacher and we don't really have a lot of time to deal with how to add fractions, we're just going to assume you know to find a common denominator, and that 1/2 is the same as 2/4, and that 2/4 plus 1/4, of course, equals 3/4. And if you don't know that, you should know that, and stop making your math teacher look bad. Know your math. This is adding fractions. You can do it. I believe in you. Okay, so what we have is we have 8 full squares shaded in, or filled in, occupying 8 squares, and 3/4. Right? 8 and 3/4. That is the area of the square. That is the answer to 2.5 times 3.5. Okay? And this is a terrible idea. Okay? This works with this one because halves are easy to work with. If this was 2 and 7/12 and 3 and 11/45, you'd be trying to find little tiny pieces of squares and you'd have no idea and you'd be guessing and you'd get it wrong and then nobody's happy. Okay? Modeling, it seems fun and it might show up as a twist question. I don't know English. As a test question. And so they're going to expect you to be able to look at it and say, yeah, that's what this means, and that we shade it both ways and we can find it, or if we can count the number of boxes that a shape takes up, and that's all well and good. But in terms of actually doing math, this is bad. You don't want to go to college and they say, how do we find 3/4 and 1/3? And you'll be like, hold on, dude. I gotta draw my box and I gotta shade it in. And I gotta get my colored pencils out because I need red, blue, and purple and these colors to make an explosion to get my answer. That's not optimal, right? So let's look at a better way to get this done. So let's go back to our first one. So flip back if you have to, or just rewrite it. It's not a big deal. 1/2 times 3/4. And let's just look at how we can do this super easy. And I'm sure some of you, because you're so smart and have a great math teacher, figured this out already. Is how can we get 3/12 from here? And hopefully you'd say, well, Ellis, duh, of course. 1 times 3 equals 3, and 3 times 4 equals 12. And I'd say, well, good job. But don't say duh to me. That seems a little bit rude. But duh, that is correct. Okay, 3/12 still 1/4. And that's all there is to it. That's all multiplying fractions is. You take two fractions and you multiply straight across and you get an answer, and sometimes you simplify and then you're done, and then there's more smiley faces, and this red smiley face goes away, and this red smiley. Why are there so many smiley faces? But it's because we're having fun. Because math's supposed to be fun. Right? Draw more smiley faces on your paper and explosions. This is a big deal. Okay? Multiplying fractions straight across. That's it. That's all you gotta do. Okay, let's go back. Let's look at this one. So 1/2 times 1/2, we sort of just assumed you knew this, but if we took the strategy we just did, 1 times 1 is 1, and 2 times 2 is 4, and we see that 1/2 times 1/2 does indeed equal 1/4. You say, hooray, but I knew that already. Give me something more challenging, Ellis. That's what we came for. And I say, okay, well, 2.5 times 3.5. It's not going to be as easy. Sorry. I hyped you up. I got to break it down a little bit. You can't just multiply mixed numbers together, okay? That's why there's a sad face still here, right? So what we have to do is we have to make fractions. So we got to turn our mixed numbers into fractions. But we can do that. That's nothing new. That's 6th grade stuff. Again, great math teachers taught you this, and this is going to be easy, okay? So 2 and 1/2. And again, I'm not going to go over how to actually do this. I'm going to assume you already know, and that you can say 2 times 2 is 4, plus 1 more is 5. So 2 and 1/2 is the same as 5 halves. Okay, and that's our first number. Times 3.5, and then same idea here. So 3 times 2, that's 6, plus 1 more is 7. So that gives us 7 over 2. So now we say, what's 5 over 2 times 7 over 2? You say, I know this, I can do this. We just go straight across. So 5 times 7, that's 35. And 2 times 2, that's 4. Okay, and if you don't know that immediately, please go home, make some flashcards, and learn that, because don't go to 7th grade not knowing how to multiply, okay? Because you had a great math teacher. They expect better from you. Okay, so 35/4, this is correct, but not the best. We don't really, generally speaking, want to leave things as improper fractions. So let's turn this back into a mixed number, and we can do that anytime we want to make a fraction into something better. We just divide using a T-bow, or top in, bottom out. So we say 35 over, or divided by 4. Okay, and we're gonna see how some neat stuff happens here. So 4 goes into 35 8 times. Let's go green. I haven't used green in a while. Okay, 8. 8, 8. That looks familiar because look, that's our whole number. That's part of our answer. We knew it was going to be 8. This had to be this. Okay, let's keep dividing. Let's see if we can keep going here. 4 times 8, that's 32. Okay, so we subtract, and we get 3 left over. 3, why does that look important? Because look, that was our numerator. That's also part of our answer. And then it just leaves our 4, and do we have a 4 somewhere? Of course we have a 4 somewhere. That's what we divided by. And our denominator, it doesn't change. It's still fourths. So 35 over 4 is the same as 8 3/4, which is the same answer we got here. And now we can take this sad face, and we can make it a happy face. And it's a big, goofy, happy face. And it doesn't even look like a happy face anymore. It's just extra goofy. But there it is. He's happy because he got the answer. And as fun as it was making this picture, don't make the picture. Do the math, okay? Be super professional about it, okay? And then later tonight, when you're on Instagram, make sure to hashtag it. Hashtag no pictures, okay? That's important. That's your homework, okay? Hashtag no pictures. Hashtag accept selfies. Okay, I'm sure your teacher has something for you to practice with. And before we go, I promised angry cats saying things. So let's there it is. I knew I had it somewhere. All right. I hope you had fun. Okay, bye.